In this video, we are going to cover the topic quadrilaterals. We will just learn about the basic of this thing. Now, you all know that a quadrilateral is a polygon made up of 4 line segments. Let us draw it. I'll take a random polygon here with 4 sides, which is called as quadrilaterals. If you see this A, B, C, D. ABCD is a quadrilateral. A, B, C, D. I name it as like that. Now A, B, C and D, these are called the vertices of the quadrilateral. AB, BC, CD, AD. So if I write A, B, C, D are vertices here. AB, BC, CD, AD are sides of this quadrilateral. Okay, and if I join the opposite vertices A to C and B to D, so what are these called as? AC and BD are diagonals. I hope this you all know. Now as there are 4 vertices, so we can say there are 4 angles also here. If we do not draw the diagonals, and we have 4 angles here: angle A, angle B, angle C and angle D. Okay students, now we have 4 vertices, 4 angles. So we have 4 vertices, 4 sides, 2 diagonals and 4 angles also. Now the side AB, BC are adjacent sides because they have one vertex in common. AB and BC I said. Then AB, AD are also adjacent sides because A is the common vertex here. Then AD, DC are adjacent where D is a common vertex. And DC and CB are adjacent because C is the common vertex. So I hope you know that adjacent sides are in which you have one of the vertex as common. Opposite sides are what? This AB is opposite to DC, AD is opposite to BC. Okay. Opposite angles also we have angle A opposite to angle C, angle D opposite to angle B. Then we also have adjacent angles. AB are adjacent, AD are adjacent, then DC both are adjacent to each other, CB are also adjacent to each other, BA also adjacent to each other. So we know what is adjacent and opposite. I hope that you know that basic concept. Now when we draw a quadrilateral, let me draw one more quadrilateral over here. Let me name it as PQRS. Again 4 angles, 4 sides. Now if I draw a one diagonal only here, so you see it is made up of how many triangles? There are 2 triangles. You can see there are 2 triangles. It's a symbol of triangles. Triangle PQR and triangle PSR. We all know what is the sum of angle of a triangle. Sum of all angles of a triangle is how much? 180 degree. Sum of all angles of this triangle is also 180 degree. So from this, can I say that sum of all angles of a quadrilateral, I'll write it as short, is 180 plus 180, which is equals to 360 degree because it is made up of 2 triangles. Yeah students, so basically it is sum of angles of triangle PSR plus sum of angles of triangle PQR, that will give us 180 plus 180, which equals to 360 degrees. So we can say that sum of all angles, meaning angle P plus angle Q plus angle R plus angle S is 360 degree, which we name it as angle sum property, ASP, that we name as for triangle also. I hope this part is clear students. We just talk about basic things about the sides, angles, diagonals of a quadrilateral, and then the sum of all angles of a quadrilateral is 360 degree. Now we'll come to different type of quadrilaterals. So there are different type of quadrilaterals. You know, 4-sided figures you have done a lot. From the first grade you are learning what's a square, rectangle, then you came to know diamond, which you call as rhombus. Okay, so we'll go for all the shapes one by one. So first type of quadrilateral comes is parallelogram. The one shown over here is a parallelogram. So again it's a 4-sided polygon. Polygon is a figure made up of straight lines which do not cross each other also. So here you see it's PQRS is again a quadrilateral with 4 sides, but it is a parallelogram. Now, what are the properties of a parallelogram? I hope you all know. So first property we say over here is the opposite sides. So what are the opposite sides here? If I say PQ is opposite to SR. Okay. So PQ is parallel to SR and PQ is equals to SR. Okay. Then here PS is parallel to QR. PS is equals to QR. So we say that here opposite sides are equal and parallel. This is one of the property of parallelogram. Another property is opposite angles are also equal. Angle P equals to angle R, angle S equals to angle Q. Okay. Opposite angles are also equal. So I'll say P equals to R and S equals to Q. Another thing, the adjacent angles. The adjacent angles are supplementary. So what's the meaning of adjacent angle supplementary? That angle P plus angle Q is 180 degree. These two. Any of the two you can take. P and S also 180 degree. S plus R also 180. R plus Q also 180 degree. Okay. These are the properties of a parallelogram. Plus one more property is there, that the diagonals here. Diagonal means if I join this PR and SQ. So the diagonals PR is not equals to SQ. Diagonals are not equal. Okay. So till here we talked about the properties of a parallelogram. Now comes the second figure. The second one is the rectangle. What is it? It is a rectangle. So rectangle is a special parallelogram, I can say. Rectangle is a special parallelogram. Parallelogram short form I'll write like this, GM. In which again the same thing, opposite sides equal. So I will write it over here as that MN equals to SR, SM equals to RN. Okay. Opposite sides equal, opposite sides parallel also, and they're parallel also. Okay. So same thing with the parallel. Because it's a parallelogram, all properties of parallelogram will be there. Special thing over here is that all angles M, N, R, S, they are 90 degrees. Yeah. So angle M equals to angle N equals to R equals to S, all are 90 degree. That's a different property here. But same thing applies here, opposite angles equal like that, and adjacent some 90, 180, that will be there also. Now another thing was diagonals. So diagonals in a rectangle are equal. So MR equals to SN. So diagonals are equal. Fine, in a rectangle. So that's the special property of rectangle, that all angles 90 degree and diagonals equal, other than all properties of parallelogram. Okay. Now comes the third shape you see here. That's a rhombus. That is a rhombus. Again, rhombus is a special parallelogram. Rhombus is a special parallelogram. Same thing, opposite sides equal and parallel works here. But here another thing, that all sides are equal, not opposite sides. All sides are equal. Okay. So here all sides, meaning this DE equals to EF equals, this is a rhombus. So DE, EF, GF equals to DG. They all are equal. Diagonals not equal. So diagonals are DF and GE. So the diagonals DF is not equals to GE. So I'll say diagonals not equal. There is one more thing, but the diagonals when they meet, yes. So the diagonals of a rhombus, DF is perpendicular to GE. So diagonals bisect at 90 degree. I've not talked about this bisect part in all of the others also. I'll go to that later on. Okay, students. So rhombus again is a special parallelogram with all sides equal, diagonals not equal, and diagonals bisect at 90 degree. Other than these, all same are same as parallelogram, like opposite angles equal, adjacent 180, add sum up to 180. Now the fourth figure that you see over here is a square. And in a square, we all know all sides equal. A square again is a special parallelogram. I can say square is a special rhombus, or yeah, special parallelogram, special rectangle. We can say that also. Yeah. So here again all sides equal, all sides equal, all angles equal, right? 90 degree होते हैं सब, sides are also equal, AB equals to BC equals to CD equals to AD, and diagonals also, diagonals equal. Diagonals meet at 90 degree also, so diagonals equal means AC equals to BD, I can say, because if I join diagonals it's AC and BD like this. Okay, that's about square. Now let's move to the fifth figure which you see over here. This is a trapezium. What exactly is this fifth figure? It's a trapezium. So in a trapezium, you see only the one pair of side is parallel. Only one pair of side is parallel here. So here what is parallel? Only DC is parallel to AB. Now what property will come over here as it is parallel? So these two angles are supplementary. So I can say angle D plus angle A 180 degree and angle C plus angle B 180 degree. There is no property that diagonals bisect and all. Over here no property like that. Trapezium is a quadrilateral in which only one pair of side is parallel. So if these two sides are equal, so if these two non-parallel side DA is equals to CB, if non-parallel sides are equal, then it becomes an isosceles trapezium. What does it become? It becomes an isosceles trapezium. Okay, dear students, I hope till here it is clear. Now comes the last type of quadrilateral, which we call it as kite. This is a kite. Kite mein now you see if these two adjacent sides are equal here. So DA equals to DC as the marking is over here, and AB equals to BC like this. The shorter sides are equal to each other, the longer sides are equal to each other. Then the diagonals जो होते हैं, they meet at 90 degree, the diagonals. So diagonal DB is perpendicular to AC. They do not bisect each other also. If you see, only this one is bisected, the shorter diagonal is bisected only, right? And they meet at 90 degree only. I hope this part is clear. Okay, dear students. Now let me read out what these lines are written over here. A square, rectangle and rhombus all are parallelograms. We covered that. A square is a rectangle and also a rhombus. A parallelogram is a trapezium also. We can say because one pair of side is parallel in that also. A kite is not a parallelogram. It's not a parallelogram because none of the side is parallel. You can see in this figure. A trapezium is not a parallelogram because all the sides are not, all opposite pair of sides are not parallel to each other. Only one pair is parallel. Yeah. Okay. So a rectangle or a rhombus is not a square. A square is a rectangle and rhombus, but a rectangle or rhombus is not a square. So these were few points you need to remember, students. Now let me talk about what I missed over there is the diagonals bisecting. Yeah. So let's take a parallelogram only. So this is the parallelogram. Let me name it as A, B, C, D. Students, one more thing, when you name it, you go in the sequence only. If you go A, B, C, C should come after B. You should not name it like that. If it is A, B, C, D, it should not be A, B and C, D you write like that. This will be wrong way of labeling. Okay, then it becomes A, B, D, C. The name should go in a sequence when you write. So you move like this, A, B, C, D. Okay, dear students, please take care of while you name a figure. So it's A, B, C, D. Diagonals, let's draw. A to C, opposite vertex we join, then D to B, opposite vertex we join. The diagonals are meeting, let's say, at a point O. So bisect, meaning that diagonals bisect each other. The meaning of that is, if they are bisecting, means this OD equals to OB. So OD equals to OB and OC equals to OC. It's dividing each other. They are dividing each other into two equal parts. That is the meaning of bisecting each other. Okay, fine. Now let's move to the theorem part of the chapter. So you see, as you have come to 9th grade, you will be learning a lot of theorems. So whatever statements we know, now they are all turned into theorem. Okay. So first theorem of the chapter is that the diagonal of a parallelogram divides it into two congruent triangles. So whenever the theorem comes, there is always a statement. So based on the statement, draw the figure first. So let the figure will be that you have a parallelogram being given. Let's draw a parallelogram again here. Please draw very neat diagrams. Name it ABCD. You can name anything PQRS, LMNOP, whatever you wish. Okay. Here ABCD is a parallelogram given to you. So whenever we draw figure, after in a theorem proving, we write given. Figure given. What is given to you? Name. You have drawn ABCD. That is a parallelogram. Then one diagonal, they are talking about a diagonal. So let's join AC. Okay. So write AC is the diagonal. I wrote what is given. What do you have to prove? What do I have to prove? That this diagonal is dividing the parallelogram into two triangles. Which two triangles we see? We see a triangle ABC. So triangle ABC is congruent to another triangle. Now the name of another triangle, I'll write it as CDA. I'll tell you why I wrote CDA, not ADC. They both are congruent to each other. This we have to prove. Now let's start with the proof. Now in a parallelogram, what do you know? We will not use that opposite sides are equal here. You can use that also, because you know opposite sides equal in a parallelogram. I'll use, as it is a parallelogram, I'll use the concept that opposite sides are parallel over here. So this AB is parallel to this, right? And AD is parallel to BC. This arrow marks tell you which line is parallel to what. Okay. So as AB is parallel to DC, so this is a transversal. AC is the transversal, right, dear student? So I can say this is equals to this. Okay. So in triangle ABC and triangle CDA, angle BAC is equals to angle DCA, alternate interior angles. Okay. The line, for which lines? AB parallel to CD, that's a transversal, so I'll say that. Okay. Now AC equals to CA, I can say that's a common side. Okay, this is a common side in both the triangles. Now as DA is parallel to CB, so this angle, and this is a transversal, so this angle is equals to this angle, right? So angle, how will I name it? This angle and this angle. So first will come this one. So ACB is equals to here CAD. CAD. Again alternate interior angles. But the lines which are parallel, for that we consider DA parallel to CB. Okay. So which congruency rules you have? You have an angle, you have a side and angle. So by ASA congruency rule, I can say that triangle ABC is congruent to triangle CDA. Got it? So triangle ABC is congruent to CDA. We got that. What is we have to prove? So I write hence proved. I hope this is clear, students. You could have also used AB equals to CD, DA equals to BC, and AC common, CA common. So by CPCT, oh sorry, not by CPCT, by side, the two triangles are congruent. Okay. Now this theorem is done. Now there is theorem number 2, that in a parallelogram opposite sides are equal. That is why I have not taken the opposite sides equal over here. So parallelogram means I used only the opposite sides. Parallel I'll use and do it. So for the second part, the second theorem, the first part is done. Like figure is drawn, everything is done. You first prove the two triangles congruent. Now when the two triangles are congruent, from the first theorem, I have ABC congruent to CDA. Now from this, what do I have? AB equals to CD by CPCT. Yeah, students? And then BC also equals to DA by CPCT. So what do we have in the figure? In the figure, if you see, AB we got equals to CD, BC we got equals to AD or DA. So that's by CPCT we got. So we can say that opposite sides are equal in a parallelogram. So the proof of the theorem 2 is in continuation from the proof of theorem 1. Okay students, I hope this part is clear. So from theorem 1 only, with the same steps, you just have to use CPCT to prove the further two steps, that the opposite sides are equal. Yeah. Now let's move to the next theorem. If each pair of opposite sides of quadrilateral is equal. So we have a random quadrilateral. Let us just draw it. This time let me name it as PQRS, otherwise you'll say that I'm always naming it as ABCD. So PQRS. So each pair of opposite sides of a quadrilateral is equal. Opposite side means PQ equals to SR and let's say PS equals to QR. These lines what I'm drawing, one single dot means this single line is equals to this single. Double means both are double, so they both are equal. Yeah. Then we have to prove that it is a parallelogram. Okay, so how do we go for it, students? First thing, again, what is given to us? Write it. PQRS is a quadrilateral. Okay, and what else is given to us? That PQ equals to SR and PS equals to QR. This is what is given to us. Okay. Now, what do we proceed further? What do we have to prove? Let's just write what do we have to prove. We have to prove that PQRS is a parallelogram. So, how do we prove that it's a parallelogram? So, again we'll draw a diagonal first. Okay, so let's do the construction part. What we join, let's say SQ as a parallel, diagonal of this parallelogram or quadrilateral, sorry. Yeah, it's a quadrilateral, huh? Now let's start with the proof. We have two triangles over here again. So I have the triangle PQS I'll take, and triangle, I've taken this triangle PQS. So P liya to its opposite is RSQ. Fine, I've taken the two, this thing. Now what all is given equal? I will prove the things first. Two triangles congruent. So I have PQ equals to RS, that's given. Okay. Then QS equals to SQ, that is a common side. Now we have PS equals to RQ, this is also given. So by what congruency? By SSS, triangle PQS is congruent to triangle RSQ. We got these two triangles congruent. Now, after congruency, I got what? That I have drawn this. So I have got that angle this comes out to be equal to angle this. Yeah. So from this, I can say that angle PSQ is equals to angle, this PSQ equals to RQS. Can I say that? I can say that these two are equal. Okay. Also, what are these angles? these are alternate interior angles, AIA I can say, but these are alternate interior angles. If these are alternate interior angles, I can say that. If this is this, so I can say that PS is parallel to QR. Similarly, I'll say that PQ is parallel to SR. So when the two lines are parallel, what do we say? If the two lines are parallel, these two pair also parallel, these two pair also parallel, we say therefore PQRS is a parallelogram as opposite sides are parallel and equal. I hope it's clear, students. We proved that. So what we just did, it similar type of proving we are doing, only we are just dividing the quadrilateral into two triangles and proving the two triangles congruent and getting the things from that. In the three theorems we did the same thing. I hope it's clear, students. Yeah, let us do two questions from your NCERT only. This one is the from older NCERT book. Very easy question. The angles of a quadrilateral are in ratio this. Find all the angles of a quadrilateral. We know sum of all angles of a quadrilateral is, so 360 degrees. Sum of all angles of a quadrilateral is 360 degrees. So let the angles be 3x plus 5x plus 9x plus 13x. Whenever the angles are given in ratio, we assume that common factor is x and do it like that, is 360. Add them all up. So what will you get? 3 plus 5 is 8. 8 plus 13 is 21. 20 plus 1 plus 9 is 30. X is equals to 360. So x comes out to be 360 by 30, which is 12. So when x is 12, so the angles are, one is 3x. So 3 into 12, that is 36 degrees. 5x is 5 into 12, which is 60 degrees. Then you have 9 into 12, so that will be 108 degrees. And then you have 13 into 12, so multiply that. What is 13 into 12? We can do it here. 3 2s are 6, 2 over here. Then you have 3 and 1, so 156. Okay, students, you can check by adding them all also if it is coming 6 12 8 0, yeah, and then carry over 2, so 9 2, yeah, 11 5 6, yeah, that's coming 360. So you have the angles over here. Fine. Now let's move to the next question, which is from NCERT book only. It says that if the diagonals of a parallelogram are equal, prove that it's a rectangle. Now you should remember the property of a parallelogram and rectangle to prove it. How do you prove that a parallelogram is a rectangle? Same properties, opposite sides equal, opposite sides parallel. Difference is the diagonals were not equal, right, in a parallelogram, but here it is given they are equal. Yeah, so ABCD, all right, is a parallelogram given to you. So what is given to us? ABCD is a parallelogram. Now properties difference I was talking about, that diagonals were not equal in a parallelogram, but here it is given they are equal. Yeah, so I'll write diagonals AC. The diagonal is AC. Came wrong. Let me draw it again. Diagonal AC and diagonal BD. थोड़ा सा टेढ़ा हो गया, तो I hope you won't mind. Diagonal AC equals to diagonal BD, right? Now, but do we have to prove that it's a rectangle? So what's a different property in a rectangle? That all angles are 90 degree. That is what we have to prove here. Okay, so to prove ABCD is a rectangle, so how can we prove? Only the difference is we need to prove that angle ABCD sub equal 90 degree hai. We need to prove that. Yeah, so let's begin. What should we do actually? If any idea you people have that what we have to do after proving so much things, you should be knowing. We need to prove two triangles congruent. Now which two triangles? The triangles that we need to prove congruent is, if I tell you, let me just color them with different color here. This A, DC if I take, yeah, and let me change this color also, this BCD. I need to prove these two congruent. Why I want to prove these two congruent? As if I make these two angles, angle D and angle C, equal, if they are equal, you know their sum is 180. If they become equal, so 90 is 180, and we got that our parallelogram is a rectangle. Okay, so how do we prove that these two triangles are congruent? So let's begin with this. So I'll take in triangle ADC and triangle BCD. What do I have? I have AD equals to BC given. AD equals to BC. This is given to us, right? Students, DC DC is common. DC CD is the common side, right? You can see the side with double colors, that common side. Then diagonals are given equal. So AC equals to BD. So it is given to you. The diagonals are equal. So by what rule the triangles are congruent? All three sides. So by SSS, triangle ADC is congruent to triangle BCD. Now both triangles are congruent. So angle ADC is a part of that triangle only. So I'll say angle ADC is equals to angle BCD. Angle BCD by what? CPCT, congruent parts of congruent triangle, corresponding parts of congruent triangles. So both the angles are equal, but you know that ADC plus BCD is 180 degrees supplementary. These are adjacent angles of a parallelogram. They add up to 180. Both are equal. So I can say ADC plus ADC, because BCD equals to that, is 180 degrees. So twice of ADC is 180. From here you have ADC equals to 90 degree, which is also equals to BCD. So two angles equal. So this implies all the angles, angle A equals to angle B equals to angle C equals to D, 90 degree. Therefore you can say that ABCD is a rectangle, hence proved. So what we did over here is we took these two triangles ADC, BCD, proved that these two adjacent angles are equal and adjacent angles add up to 180. Both are equal, so each of them become 90. Now you know opposite angles equal. If this is 90, this is 90, this is 90, this is 90. So it becomes a rectangle. I hope this part is clear, students, to you. So we have covered few theorems, the basic concept of quadrilaterals, and one or two questions from NCERT in this video. The next video, which will be the other continuation of this chapter only, will include other questions from the chapter. Okay, students. So I hope your concepts are clear now. Try to practice these questions, and in the next video I'll come up with the other questions of the same exercise. Till then, bye.